Yes, hi everyone. I'm coming today with some interesting topics which are related to the basics. Okay, actually, this was posted by one of the student in the group as a doubt. So, as they are very important in the examination point of view, so I just want to cover them in detail and in brief. Okay, I just want to make the discussion very simple, and I just want to cover this stuff very fast. Okay, coming to the topic. The topic is about enzymes. So the basic thing I just want to describe about these enzymes are coming to the you just need to know about this haloenzyme. Okay, this is actually a functional part of enzyme. The functional part is nothing but an active part. Functional part is nothing but active part, and it's this haloenzyme is going to contain a combination of two things. That is, one is protein part and second one is non-protein part. Okay, so protein part is again apoenzyme. The protein part of this haloenzyme is called as an apoenzyme, and the non-protein part is called as a coenzyme. I hope you are very clear. The functional unit of an enzyme is haloenzyme. The haloenzyme contains a protein part and a non-protein part, and a protein part is apoenzyme and non-protein part is coenzyme. And coming to the vague statement, that is, most of these enzymes and most of the enzymes are proteins, and I mean, you know that proteins can be denatured at a higher temperature. So enzymes can be denatured at a higher temperature. That's one of the important statement you need to make a note. Apart from these, recently a few RNA molecules they have similar properties of enzymes. So enzymes, most of the enzymes are proteins and very few are RNA. Okay, few RNA molecules can also act as enzymes. That's the actual meaning of the statement. Okay, so want to go for the next move. I just want to go for the next move. The next move is about the classification of enzymes. I hope you guys knows well about this classification. If you have remember, there is something called as an OT hill. Okay, we used to remember this as an OT hill. So if you go in detail, that is the one O is oxido reductases. One O is oxidoreductases, means there will be transfer of hydrogen molecule AH2 plus B is going to give rise to A plus BH2. Means these are the enzymes that are involved in the oxidation and reduction reaction. And the second one is T, that is transferases, where there is a transfer of a functional group 1 from one molecule to other molecule. For example, AX plus B gives rise. So there is a transfer of this X. So it is going to be BX plus A transfer. This is transferred from A to B, that is transferases. And the third one is H, that is hydrolases. Hydrolases are the enzymes that involve in the hydrolysis of the compound or the molecule. For example, A, B plus H2O gives rise to AH plus BOH. This water molecule causes the hydrolysis of this molecule and gives rise to this AH and BOH. So this is called as hydrolysis. So these are the ones. So we are going to deal now with ILL. We are done with OHT. Now we are going to deal with ILL. So next, I is isomerase. I think you know the meaning of isomer. Isomer is a similar molecule with a change of orientation of things here and there. They are similar almost, but there will be some sort of structural change, isomers. Okay, so that is called as an isomerase, and then followed by two L's, that is lyases. Enzymes that are involved in the addition or the removal of the molecule, like water. They can remove or add water. They can remove add ammonia. They can remove or add CO2. Such molecules are called as lyases. A, B plus XY gives rise to AX plus BY. So this is what a lyase is. And the last one is ligases. Ligases are the one that's going to catalyze the synthetic reactions, which where two molecules are joined together and ATP is produced. Two molecules A and B, they are joined together, and finally the outcome is an ATP. So this is the meaning of ligases. Ligases, two molecules combined and they release an ATP. And I hope you are clear with this basic classification. They may ask a question related to the basic classification. So you are clear with the structure, all these haloenzymes, apoenzymes, and all this. And I hope you are very clear about this. So the next important thing I just want to discuss are the factors. The factors that are affecting these enzymatic activity. Okay, these factors. Coming to the basic things, I just want to discuss about the concentration of the enzyme first. So because this is the one that's going to decide. If you take the relationship of these, the concentration and velocity, it's just like a straight line. Excuse me. So as the concentration of enzyme increases, the velocity increases. Means the velocity as well as the concentration of an enzyme are directly proportional to each other. This is a simple thing. The concentration of an enzyme is directly proportional to velocity of the reaction. I hope you are clear with this. So the next is second factor is very important factor. Many of the questions will come under the second factor. Is about the concentration of the substrate. There is a slight variation when you compare with the concentration of an enzyme. Increasing in the substrate concentration gradually increases the velocity of the reaction within the limits of the substrate level. So that's what means. If you go through the graph of this substrate concentration as well as velocity, there will be a drastic increase, then after slopes, and at a level where the saturation occurs, it remains constant. So if you categorize them into A and B and C, so A is something like directly proportional almost, B slight decreases, C they become constant. So again I'm just repeating this statement. Increasing in the substrate concentration gradually increases the velocity of the enzymatic reaction within the limited range of the substrate levels. Whenever the substrate levels are gone, the reaction will become constant. Okay, so that's what it means. So in this we need to learn about few things. One is, in particular about this graph, and there is some sort of mathematical equations, and I want you guys to learn about this mathematical equation in detail. Okay, so this mathematical equation is something like the reaction. Okay, E is enzyme plus S means substrate, so it gives rise to formation of ES, that is enzyme substrate complex, which again dissociate into enzyme plus protein. So this forward reaction is stated with a constant value, that is K1. This backward reaction of ES to E plus S, this is stated as a K2 constant, and this is stated as a K3 constant. So obtaining from these constants, they have come out with a formula that is called as a Km. Km can be called as an mm constant. Mm constant is nothing but Menton's constant, or it can also be called as a BH constant. The BH constant is called as a Briggs and Haldan's constant. So it can be called as these constants. So obtaining from these K values, they came out with this Km, that is Km is equal to K2 plus K3 by K1. I hope you are very clear. K3 is here, K2 is here, and K1 is here. So Km is equal to K2 plus K3 by K1. So with this, I just want to explain what is Km actually. So if you go through the graph again, okay, that is substrate concentration plus velocity graph, which slopes back. So this value is called as a velocity. This is the maximum velocity, right? So it is called as a Vmax, right? This is the Vmax. But in the A category, okay, there is a constant proportion up to this level, right? So this is called as Km. This point is called as a Km point, where it strikes half of the Vmax. So this is Vmax. This point where Km strikes is called as a half of the, and Km value means it's almost like proportional to each other. Means the substrate concentration is directly proportional to the velocity. Such value is called as that at that point it is called as a Km. So I just want to give the definition of Km. Let's make it very simple. The Km can be defined as a substrate concentration. It's on substrate, right? So it is a substrate concentration to produce half of the maximum velocity, right? So Km is nothing but it is the substrate concentration to produce the half of the maximum velocity in the enzymatic reaction. It can indicate that half of the enzyme molecules are bonded within the substrate molecule, where the concentration is equal to Km value. So very clear, Km value is the substrate concentration where it produces the half of the maximum velocity. And you know, the Km value of majority of the enzymes in the human body is 10 to the power of minus 5 to 10 to the power of minus 2 moles. You need to make a note of this value. This is an important value which was asked in the exam many times. And what Km is going to do, okay, Km is going to give a hint. Km values are generally constant for enzymes, and it's a characteristic feature of a given enzyme, okay, and it represents the strength because Km is going to form Es, which was discussed in the previous slide. Okay, E plus S is going to form Es. So Km is going to give an information about the enzyme substrate complex. So a low Km indicates strong efficiency, means a low Km. If Km values are low, there is a strong efficiency between E and S because it's opposite. If Km values are high, there is a weak efficiency between this enzyme and substrate. So Km value is going to give the strength of Es, and it's going to determine how efficient they are. If it is increasing in the Km, so there will be decreasing in the efficiency. If there is increasing in the Km, there will be decreasing the efficiency. If there is decrease in the Km, there will be increasing the efficiency, because it's going to give an information about the formed Es complex rather than the affinity between these two, right? So the normal values ranges from 10 to the power of minus 2 to 10 to the power of minus 3 moles. So this is what about this Km values, the half of the maximum velocity and the substrate concentration and all the things. So from this they obtained an equation. They will ask this equation, that is V. V is nothing but measured velocity. If you are measuring the velocity of an enzyme at a particular point, they gives the measuring velocity. V is equal to Vmax. Vmax is the maximum velocity into S. S is nothing but the substrate concentration by Km. Km, you know that Km is equal to K2 plus K3 by K1. K2 plus K3 by K1. So Km plus S. So this is an universal question. Whenever they are keeping an exam on enzymes, this question is must. So V, the measured velocity, is equal to Vmax, that is the maximum velocity, into the substrate concentration by Km is equal to this plus the substrate concentration. So this is an important formula that you have to remember at any cost. So after this, I just want to discuss about the third factor, that is effect of temperature. So the effect of temperature, as already discussed, it is almost like a proteins, so it have a similar effect like that of proteins. If you take the graph of temperature and the enzyme velocity, it increases. It is a bell-shaped graph. So the velocity of an enzyme reaction increases with increasing in the temperature up to maximum, and then it declines. and it's a bell-shaped graph, please make a note. And the optimum temperature at which majority of the enzymes in the human body are active is 40 degrees to 45 degrees centigrade. This is an important MCQ. But there are few exceptions, that venom phosphokinase and muscle adenylate, and this is also a kinase, which are active even at 100 degrees centigrade. So whenever the temperature ranges these degrees centigrade, few of like 40 degrees to 45 degrees is a maximum, is an optimum temperature at which majority of the enzymes are active. When it crosses 50 degrees centigrade, there will be denaturation, but there are few exceptions. These are the few exceptions you have to make a note. So we are done with the third factor, temperature, and now we are moving to the fourth factor. The fourth factor is effect of pH. It has a similar effect, like if you take increasing in the pH, decreasing in the pH is nothing but increasing in the H plus ion concentration. I hope you know this. So whenever there is increasing in the H plus ion concentration, that's going to affect the enzyme directly or indirectly. So if you take the graph between the pH and that of the velocity, so it is again a bell-shaped graph. So majority of the enzymes are very active at pH of 6 to 8 degrees. That is the neutral pH almost. So however, there are few exceptions that we know about this. Pepsin, which is active at 1 to 2 pH, and we know that acidic phosphatase, we know that is active at 4 to 5 pH, and we know that the alkaline phosphatase, alkaline means it is active at alkaline levels, that is 10 to 11. So please make a note. We know these pH values, please make a note. It's a bell-shaped again. Similarly, optimum is 6 to 8. Few exceptions, that pepsin is 1 to 2, acidic phosphatase is 4 to 5, and alkaline phosphatase is 10 to 11. So we are done with the fourth factor. Now we are moving towards the fifth factor. Fifth factor is the effect of the product concentration. Means A plus B is somewhere giving AB. AB is the product. When there is increasing in the product concentration, it's going to have an influence on the reaction. So whenever there is increasing the product concentration, it's going to act on these initial ingredients or the catalyst that is helping the reaction to occur. It's going to act there and it's going to decrease. So whenever there is increasing in the product concentration, definitely there will be decreasing in the velocity of the reaction. I hope you are very clear with this. Okay, so this is the fifth factor we are done, and now we are moving towards the sixth factor. The sixth factor is the effect of activators. So there are few things that are going to activate the thing, activate the reaction, activate the velocity. So if you take the structure of enzyme, the enzyme is going to have somewhat like an active site. Active site is a very flexible one, and it modifies according to the substrate. The substrate is going to come and it's going to insert in the active site and the reaction goes. This is what actually the mechanism. So the few activators that are going to activate and that's going to change the velocity. So they can be categorized into two types. One is the metallic cations. So majority times the activators are mainly cations. You can see Mg plus 2, you can see Mn plus 2, you can see Zn plus 2, you can see calcium plus, you can see CO plus 2, you can see Cu plus 2, you can see Na plus and K plus, and there are many. And very few times you can see that anions. Anions, mostly you can see Cl minus. That's for, that too for MLAs you can see this. Okay, so these are the two category of ions that are available. Majority of the ions that helps in this activation are cations, right? So the next one is like two categories of enzymes require metals for their activity. They are A, that is metal activated enzymes. So they need metals to get activated. So these are the metal activated enzyme. The main important thing is that metal is not tightly held by the enzyme and can be easily exchanged with other ions. Means here the metal is not tightly bonded. It is not tightly bonded. and they can exchange the places. Like the active site can be exchanged with one metal to another metal. For example, like Mg+2 can be replaced by Ca+2 while you're going for ATPase enzyme. So similarly, so the second category is metalloenzymes. First category is metal activated enzymes. Second category is metalloenzymes. Metalloenzymes, these enzymes hold the metals rather tightly, which are not readily exchanged. Means here the bond is very weak. In the metal activated enzymes, here the bond is very tight. Here there will be an exchange. Here there will be no exchange. Okay, so this is the factor. This is the effect of activators. So I just want to make a note. I just want to add in these activators. Coming to the metalloenzymes, there are few things you have to remember. That is, the metalloenzyme in phenol oxidase is copper. Please make a note of this. These are asked. These are previously asked questions. Most common, that is pyruvate oxidase. The metalloenzyme is manganese. And the last one is cytochrome oxidase. You have a metalloenzymes like iron and copper. Okay, I hope you are clear with this. And coming to the activated site, the activated site is going to have an enzyme structure. I just want to add one note about this activated site. The activated site is going to have two locations. This you have already described this activated site. This is an activated site. It's going to have two components. One is substrate binding site. Second one is catalytic site. It's going to have two sites: substrate binding site and catalytic site. And this is a structure, so it's going to contain amino acids. And the major amino acid which is frequently found in the active site, means active site is also a structure. It's going to contain amino acids. We know that amino acids are 20. 21 is 21st amino acid is there, but majorly 20. So out of this 20 amino acid, the amino acid that is most frequently found at the active site is serine. Okay, so I hope this is it's already crossed 23 minutes. So let's close the discussion, and I hope this is a useful video. Signing off, Dr. Srikanth, MDS Konkan, and thank you.